Hi boys and girls, here's a short video to guide you to identify the valence electron from our electronic configuration. Since we have already learned the electronic configurations, how to construct it from the proton number, so it is also important for you to identify the valence electron and also the valence electronic configuration. So now you have already learned your alpha principle, in which electrons are arranged according to the increasing energy level, from our 1s to 2s to 2p, 3s, 3p, and so on, according to your raindrops diagram. So now let's look at the examples over here. Say the first examples over here, we have 1s2, 2s1. So our valence electron, you can find it from the highest values of n. Okay, highest value of n. So in this case, 2s1 is our highest values, 2. So in 2s orbital, we have only one electron. So that is your valence electron. The second example, 1s2, 2s2. There is 2 electrons in the highest orbitals over here, 2s. Therefore, you will have 2 valence electron. The next examples over here, you have 2s2, 2p2. Since the value of n's are the same, so we will consider both subshell, 2s and also 2p. So adding up the electrons together, 2 plus 1, we got 3 valence electron. So remember, you need to consider the highest value of n. And if you got 2 value of n which is equal, then we would take both subshell. Then next examples over here, 2s2, 2p2. So 2 plus 2, you got 4 valence electron. The next example, 2s2, 2p5, altogether 7 valence electron. So how about if we increasing the energy level? From 1s2, 2s2, 2p6, 3s2, 3p4. So for now, the highest value of n turns into 3. So we consider 3s and also 3p subshell. So 3s2, 3p4, 2 plus 4 together give you 6 valence electron. And the next one, we have 3s2, 3p6. So altogether, 8 valence electron. So it is simple if it's only involve S subshell and also P subshell. But what if it involves the electrons in our 4s and also 3d orbitals? So remember, Madam have told you before this one, when it comes to 4s and also 3d subshell, there is some complication and you need to be very careful and check it properly. So when it comes into 4s and also 3d orbitals, we need to consider both orbitals at the same time, even though the highest value now is 4. But you still have to consider the 3d subshell. Okay, so let's look at the first example here, 3s2, 3p6, and 4s2. So in this case, the highest value is number 4. Okay, so the n value equals to 4. So for S2, we have 2 valence electron. Okay, but if we have more electron fall into the 3D subshell, let's look at this. The second example is here, 3s2, 3p6, then you have 4s2, 3d1. So whenever you see 4s and 3d appear on at the same time, then you have to consider both of this. 4s2, 3d1. So altogether give you 3 valence electron. Alright, consider both electron in 4s as well as 3d. The next example, you have 4s2, 3d2, give you 4 valence electron. Next example, give you 4s2, 3d5, and altogether give you 7 valence electron. And over here, we have 4s2, 3d7, give you 9 valence electron. And the last one, 4s2, 3d10. So altogether, give you 12 valence electron. So in this case, you need to bear in mind that we will continue in our chapter 3.1 to recall back about this valence electron. Okay, so all of this will be in our transitions element. Okay, all of this is the electronic configurations for our transitions element. All right, so now we have one more case if you have more electron and you can't fit any more into 3D, because for the example just now you have already reached the maximum whereby you reach 4s2 and 3d10. Okay, 3D have already fully filled. So if let's say you got more electron, you should go into the next subshell, which is 4p. So if you look at this example, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and the next electron fall into 4p. So give you 4p1. So over here, okay, 4s2, 3d10, since 3d orbital, 3d subshell has already completely filled, then we need to change the position. So we change the positions a little bit. So 3d10 go in first, and then after that 4s2, and then continue with our 4p1. So now you can clearly see the first energy level, second energy level, the third energy level, and the fourth energy level. So when you reshuffle or you rearrange back the positions of 3D and 4S, okay, then it's clearly you can see the outer layer 4S and 4P subshell. Okay, so this example is similar like the first few examples that we discussed just now. 4s2, 4p1, altogether 3 valence electron. So in this case, since 3d10 is already fully filled, and the next electron is already entered 4p subshell, then we don't consider 3d anymore. Okay, we only consider the 4s subshell and the 4p subshell. So in this case, you have 3 valence electron. Then the next example, 3D we're not considering. We only consider 4s, 4p. So 4s2, 4p2, 4 valence electron. 4s2, 4p3, 5 valence electron. 4s2, 4p4, 6 valence electron. 7, and 8. All right. All right, so madam repeat again over here. So if the electrons involved in 4s and 3D, and 3D is not yet completely filled and you haven't entered 4p subshell yet, then we will consider 4s and 3D. Okay, until 3D is fully filled, but it haven't entered 4p subshell yet, we still will consider the 10 electron inside 3D as our valence electron. But once the electron enter 4p subshell, then we only consider 4s and also 4p subshell. So in this case. So we are going to repeat and revise in our chapter 3.1 later on. So I hope this video will help you to identify the valence electron from the electronic configurations. All right, thank you.